Hi, everyone, and welcome to the final 9 days of class. Seems so fast. So in this module video, we are going to talk about chapter 4. That is the last chapter I'm going to have you look at in this class. The outline assignment that you have due and your final essay. So let's think about chapter 4 here and let's look at this. Chapter 4 is inductive arguments. This chapter will cover the use of statistical evidence in arguments, reporting of statistical data, and the use of causal generalizations. So statistics, why is this important? Well, statistics will make your argument stronger, but we need to be able to pick the correct statistics and make sure that they are accurate. Inductive reasoning, evidence offers strong support beyond a reasonable doubt. Okay, so think about it. You hear that all the time if you're watching court shows, beyond a reasonable doubt. It doesn't mean that you know for 100% that the person did the crime, but there is so much evidence that you can't think that they did it. Okay, so keep that in mind. It's not 100% certain, but the evidence gives heavy weight on the certainty. It's most likely to be true. Okay, so using evidence. The strength of a conclusion is based on the quality of evidence used to support the conclusion. So as you're writing your final assignment, think about it. If you are going into law enforcement, then you want to really focus on the strength of this evidence that you're presenting for this argument. If you're not going to law enforcement, but you still want to win an argument, then you need to say, okay, I'm going to win this. Keep that in mind. I'm going to win this argument by presenting this evidence. Now, if the evidence is not there, then change your reasons or change your claim in your argument. But make sure you look at the evidence. So let's look at this, the conclusion. Let's say you're driving a car, and here's the first cycle. You're driving the car, and boom, you hit a bump, and the car misfires. You hit another bump. Again, the car misfires. Smooth road, no bump, no misfire. So inductive, it doesn't mean that 100% on the next cycle, if it bumps, it's going to misfire. But you pretty much say, okay, it's happened twice, and then on the smooth road, it didn't happen. Therefore, on the third cycle, bump, it's going to misfire. That's the conclusion. Deductive reasoning is, let's say, the horn. You know that the horn is exclusively powered by the electricity from the battery. So if the battery is dead, it's clearly not going to work. That's deductive. Another way to explain inductive is, think about your car stops running. You're driving your car and it stops. If you look at this and you say, I don't know if it could be the gas. It could be, a faulty battery. It could be many things. You're going to use your inductive reasoning to figure it out. If you know that before you left the house, you were on empty, then the deductive reasoning is pretty much it's going to be the fact that you had no gas. Okay, let's go on to the next one here. So, drawing generalizations from known facts, research statistical evidence, finding truth by making observations. That is what you need to do. So, as you have your issue, and if you've already submitted your issues, I've okayed them. If you haven't submitted them this Sunday, until you wait until Sunday, then I will approve them by Monday morning. Once you have your issue, you need to give us a claim. Yes, I support this, or no. And then you're going to find the truth. I want you to find this evidence, the statistical evidence that tells us, yes, this is why this is happening, or no, this is not why it's happening. Statistical evidence, why we use it, again, control over the unknown, make predictions and decisions and anticipate accurate information, and connect patterns in our life. The patterns and the decisions and predictions is probably one of the strongest parts of statistics. You're not going to make the statistics, you're finding the statistics. And if you find evidence, for example, if we're talking about voting, and we want to say, who do we think the next president's going to be? And we look at statistical evidence. Well, these states, every 20 years, they vote this way. Therefore, this year, it's the 20th year, they're going to vote, boom. So you're making these predictions based on the patterns from the past. Look at the numbers. Numbers shouldn't lie. That's why you need to really analyze this information to see, are they lying, are they not, and how can you lie with numbers? So that's what we're going to look at. Gallup polls, right here, this Gallup poll and the Harris poll, these two, they are huge companies that are hired by many groups. They can be hired from Coca-Cola, Pepsi, to even political groups. And they survey, you might have been called, because they call people or they reach by mail and they survey people. Hey, on the next election, who are you going to vote? Hey, do you like Pepsi or Coke better? They are not working. They're not part of Coca-Cola or they're not part of Pepsi. They're just a survey company. And they are there to give us information on how people will vote, how people feel about a certain situation. Inference from statistical evidence. So here on this Gallup poll and Harris poll, I'm going to pause right now and I'm going to show you how you can use this for statistical evidence as well. Okay, so now we are in the Gallup poll. This is Research America, Discovery, Innovation, and I will put these links in your resources. For example, here is the Gallup poll, and you can see all the different studies that they do, all the different surveys. 18 to 29-year-olds on selected issues related to COVID-19. America's views on science and health. America strongly support human genetic testing. You go down to, let's see here, Americans' views on child abuse and neglect. America Speaks poll data summary, volume 18. America say President Trump should assign high priority to science and technology. You can see the years too. Remember, think about the CRAP test. You want to look at the years when these were conducted because people's ideas and values and views can change. So let's look at this one here. If we were to select that on COVID-19 and 18 to 29-year-olds, here it says Research America, 18 to 29-year-olds on selected issues. Then they give you the survey methodology. This is what they were trying to do. This online survey was conducted by, okay, and it tells you by whom. Look at that, among 1,013 adults. Remember, 1,000 or more is a great number for surveying. 18 to 29-year-olds. The survey was a theoretical sample error, and you don't have to worry about too much about the numbers there. But here it says comparisons are made to the online survey conducted in 2020 among 208 adults. So let's go here and see what they found out. So, in thinking about threats to your health, how important is it that elected officials at all levels listen to the advice from scientists? So this is from 18 to 29-year-olds. The majority, 59%, believe it's very important, and a 5% not at all important. Okay, so if you were to report on this, you could say, yes, the majority of 18 to 29-year-olds believe it's very important for the political officials or elected officials to listen to the scientists. Then here's another one. In thinking about threats to your health, how important is it that elected officials at all levels listen to the advice from scientists? This is the difference between January to March. So here's a pattern we can look at. In January, when we really didn't know much about COVID, it was 47% felt that it was very important. But look in March when COVID really hit, 60%. So it jumped about, about 13, 14%. So you want to look at those numbers and then you can make like, hey, as the cases grow larger, more people are going to believe that we should be listening to scientists. That's a guess that you can be making on the evidence. True or false? Vaccines are used to treat viruses and help patients get well. True, 66 believe it's true. Now, is this an accurate statement? Maybe, maybe not. You have to look, do viruses actually help patients treat viruses? You have to look that up, but this is what 18 to 29-year-olds believe. So 18 to 29-year-olds have a misconception about how vaccines work. Misconception means that's not accurate. So 66% believe that this is true, and vaccines are not used to treat viruses and help patients. So that's where you could say 18 to 29-year-olds do not have all their facts, do not understand how vaccines work, but they do believe we should listen to scientists. So what we want to look at here are 3 questions. The characteristic of interest. What is it that we want to find out? In the last one, they wanted to find out how 18 and 29-year-olds, their views on issues on COVID-19. Whom do you want to find out? That's the target population. That was about 18 and 29-year-olds. And whom can I study to get accurate answers? 18 to 29-year-olds. You want to make sure that the sample is large enough, 1,000 or higher is good, random and representative. What that means is you want 1,000 selected individuals. It's not biased. You don't want just 18 to 29-year-old males. You want 18 to 29 males and females. You don't want them to load them with leading questions. So we want to make sure that the questions they were asking is not, viruses, what were they saying here? Medicines. Okay, vaccines. If they say vaccines help viruses, right? That's a loaded question. It's, do vaccines help viruses? Yes or no? That's it. So that is not a loaded question. So you want to look at that as you're getting your information. Eliminate difficulties. That's why we have causal generalizations. They eliminate difficulties, prevent future problems, and they help with human curiosity. So as you research, please use statistics. Find them. Use the resource page that I will provide in this module, where I will have different areas that you can go in for statistics. Google statistics on your topic. Don't be biased. Don't just Google things that will support how your claim is. You might end up changing your claim based on the information that you gather. Good luck.